I lost track of all the people that have joined. They're coming in all at the same time. So welcome to the Innovation Lab series. You haven't missed anything. We haven't started just quite yet. We're letting everybody trickle in. Thank you for joining us today. Mandar, welcome. It's good to see you. I'm sneaking peeks over at the other Zoom screen. Simon, Mark, Randy, welcome. Peter, welcome. It's good to see everybody. Thank you all for joining us today for the Innovation Lab series. We'll be starting in just a few moments. All right, well, it's about 1:03. I know that there were several more people that were interested in attending today, and maybe they'll be able to pop on in a little bit. But in the interest of time, so that there is plenty of time for the interaction, because I know that you are all here to see Professor John Chun and not listen to me, I'm going to just jump right in. So hello, everybody. Welcome to the AI Experts Network's AI Innovation Lab series. In the past, we've been meeting probably every other month as the AI Experts Network, and I'm hoping that this Innovation Lab series will be an exciting new chapter for us as we collaborate, innovate, and make a difference together. We will be only having 6 more Innovation Lab session series, lab sessions in this 2023 series before we look forward to seeing all of you at the AI Summit. So if you're interested in leading a lab session or interested in hearing a specific topic or from someone, please reach out to me and let me know. I would be happy to help make that happen. So also, thank you all for transitioning with us from Xavier Health. A few of you may have heard me say this before, but I'll go through it just one more time, if you all would humor me. At the Apto Wraps Healthcare Products Collaborative, we are continuing to host the AI community that has been growing and thriving since 2017. Not only do we have this AI Experts Network that was specifically designed for you so that you can talk shop right away without having to stop and go over basics, we also have the culmination at our annual AI Summit. And I'm excited to share, for those of you that are in Ohio or excited about Cincinnati, we are returning to Cincinnati for the 2023 AI Summit. So do me all a favor and mark down in your calendars November 14 to 16. I hope that you will all be able to join us for conversations and interactions like this. You will get to hear from our AI working teams. They've all done great work. There are some people here that represent those working teams. Their work has been cited by the FDA, the WHO, used as foundation for standards that you all probably work with on a regular daily basis, and have earned great global credibility with their work. If you're interested in joining that part of the community and engaging in that way, please also don't hesitate to reach out. So we are very excited today to have the Large Language Models, Tools, Automation, and Future Applications in Health Tech presented by Professor John Chun. And before I turn it over to him, you are all familiar with our mission, which is around inspiring collaboration, leading innovation, and making a difference. But what you may not all be familiar with is our mission here at the AI Experts Network. We are continuing this mission that you all created as a network together several years ago to establish a collaborative forum of AI experts across academia, government, and industry, and accelerating the development of AI solutions for the benefit of the global healthcare community. These lab sessions focus on being a community where we can have the discussion, the free flowing of ideas, a place where you, like-minded people, especially in artificial intelligence, can have these discussions. So with that, I would like to introduce our session and lead this that is being led by Professor John Chun this afternoon, and turn it over to him. Professor Chun is the co-creator of the world's first AI for the Humanities curriculum, which is seen at Kenyon College. He has mentored hundreds of original data science, machine learning, and AI research projects. He has also been a Silicon Valley entrepreneur, co-founded and led one of the world's largest privacy and anonymity web services, as well as developing the first web-based VPN appliance. He's also served as the director of development at Symantec, and also a CTO for a major third-party disability insurance and absence management firm in Silicon Valley. We're very excited for the expertise, conversation, and the engagement that we are all about to partake of for the next hour. And without further ado, I'm going to turn this over to Professor John Chun. I'm going to stop sharing and give you the screen, Professor.
All right, great. Oh, let's see, I lost you. Okay, so thank you, Timothy. I'm going to share my whole screen here, and I apologize. This is kind of last minute, and I've been working very hard, and I erred probably on too much, but feel free if you have questions. I will, let me go to my presentation slides. And as Timothy said, I've worked in AI for the last, 10 years. And before that, I was in Silicon Valley. I did startups in network security and privacy and anonymity. And before that, we actually have a shared background. I was in healthcare, and I dropped out of medical school after 2 years to move to Silicon Valley and work on startups. So I've also worked in finance and in Tokyo and other things like that. So one of the unusual things, I've been really passionate about what's been going on with let me see. I'm just going to do these slides if that's okay. So one of the things that's really exciting has been watching these large language models. We've been working on them since 2019 with GTP2. Our first project was to do an improv bot. And so a lot of these frameworks that we're seeing now, like LangChain and AutoGTP, they're actually things that we were working at in trying to build AI agent based upon GPT-2, which was much, much inferior to the current model. But one of the things I wanted to, I'm sure everybody here is aware, is this has been phenomenal, not only in terms of the growth and user uptake, but if you look at GitHub and you look at the stars and how quickly, for example, if I go here, I want to show you, here is a list of the most popular trending repos on GitHub. And if you look at these, you'll see within the past month, 1,500 stars. I've never seen anything like that before. And if you go down here and you look at how many of these are AI related or GPT related, you'll see number 1, number 3, number 2 is actually ML ops to actually operationalize these, number 4, number 5, and all of these are phenomenal. So it's a really exciting space to be working on right now. What I'd like to cover today is the evolution of these large language models, survey the field, talk about how people are extending these large language models. And if we have time, I've done some background and kind of surveyed a couple articles in medical research as well as medical tech startups. So on the first one, the evolution of large language models. I don't want to go into the whole timeline, but if you look at it, there's been maybe 5 seminal points in the last several months. So if you go back to 2012, that's when the whole deep neural network revolution began with convolutional neural nets and the ImageNet results, and soon crowded out all other models in terms of state-of-the-art, on the leaderboards. The current cycle that we're in with large language models, 2017 with Attention is All You Need paper by Google. And that is the foundation. We'll talk a little bit about that. And then in 2019, in August, they publicly released the GPT-2 model, which we worked on. And then November 30th, everyone knows about the chat. And then March 14th, which is the fourth version of that. You probably, if you've looked at this, and I know we may have a mixed crowd, so I don't want to go too deep into the technology, but this is a canonical form that you'll see when people explain the transformer models. It is an encoder-decoder stack. And I won't go into this. What I will do is I will post my my slides with some details. So if you are mathematical, if you want to dig into the math, we can go into that. But I will point you to this instead and talk, which I think is a more useful visualization. This is some of the most intuitive visualizations I've seen, and it talks about the transformer architecture in a step-by-step way. But if you don't mind, Timothy, I'm going to elide over that because we could get deep in the weeds on that. And let's talk about ChatGPT from a higher level abstraction, which is the transformer architecture. But more importantly, it's the instruct GPT, the reinforcement learning with human feedback, and the prompt engineering. Those are the aspects of the technology I'd like to focus on. And if we have time, we can go back and actually drill into these a little further if that comes up.
And,
And one of the
Profe-
interesting things, Timothy, should I actually go into that?
Professor, it's up to you, but I did want to let you know that this audience is an audience of AI experts. So feel free to go in as deep as you'd like, or what do whatever you would, whichever direction you wanted to go, but don't be afraid if you want to dive into the deeper expert level conversation. That is what this network is for.
So these are kind of a good outline of the steps. We have the tokenization of the plain text. Then we have an embedding layer, and then they actually have positional embeddings using cosine and sine in order to have the temporal order of all the tokens to embed that into and then they combining the temporal order, then they have a new embedding that encodes not only the traditional word embedding, token embedding, but also the positional information. And then what they do is there is some tensor mathematical operations on both the query and the keys, the preposition, what you're and this is kind of like a data. I always analogize this to a database lookup where you have your queries and your keys are your index into your data structure. And then your scale, those get softmax and normalized in order to get scale probabilities. And then the big thing that drops out of all of this is the contextualized embeddings, which is dot product of the scaled probabilities that we calculated over here. And then also values. And values could be a variety of semantic things. It could be like place or nouns or conjugation. It has semantic meanings in that. And then each one of these, not only do we have a single head, but we have multiple heads deep, and each one of these heads can learn a different thing. They can learn about what is the topic, what is the sentiment, what is the any other relations. It could be semantic. It may not map punctuation, emphasis, capitalization. Also, these heads can learn all sorts of different things independently. And then things like BERT have 16 of these multi-layers, attention heads, these attention head layers stacked upon each other. And then they have also various other things, fully connected networks and other things, feed forwards in between them. So again, if you look at this, this is the kind of a good representation of your query, your key, and your value. So you do the mathematical multiplication of the tensors, you scale them, you can optionally mask them, you do a soft max to normalize the probabilities, and then your value is kind of your query or the value that you actually extract, whichever matches your query. So that's kind of maybe we can go later into that. But again, I would there's two videos here that are footnote in here that are more mathematical and visual about the embedding layers, rather than I've always found this kind of insufficient, especially when I talk to my students about this. But the transfer architecture, we talk about how it's one of the secret sauces of this. It's been very interesting if you listen to Sam Altman recently, and they talked about the performance increase they've had with GPT-4. He says it hasn't been anything, obviously they've never released anything definitive on it. It's a little bit increasingly less open AI, but he did intimate that it was a lot of little things and nothing major. But the last kind of confirmed architecture details that we have come from the chat release on the OpenAI website. So their unique training, some of the secret sauce, again, it wasn't invented by OpenAI, but they were the first to operationalize it and certainly present it to the public in a seamless chat interface that caused it to take off. So a lot of this is having very sample efficient fine tuning. That was really, in my mind, the breakthrough, using reinforcement learning to train a policy network. And rather than, just brute force, collect a large data set. So a few high quality, strategically putting human in the loop, One of the things I thought was really interesting is humans are notoriously poor in terms of inter-rater agreement on subjective things like sentiment. So one of the things they actually borrowed from kind of cognitive science and social science studies is that humans are very good at ranking. And so they were able to get a very strong, clean signal in terms of their fine tuning by using a ranking system here rather than, assigning some value or things like that. Relative pitch versus perfect pitch is maybe a good analogy. Uh, One of the things too that is very interesting is the prompt engineering. And since we do have a technical crowd, I hope we go into some. I have three research papers from the medical field using GPT that will drill into this more. Obviously, prompt engineering, you can do a zero shot where you just ask a question. You do a one shot where you give an example of a question and answer and then a question, or you can give N shot learning. Typically, I see that 3 to 5 range where you give 3 or 5 examples. And the last one, question, answer, question, answer, question, answer. The last one, you leave it at the question and it continues. It's a text completion. The context window is about 4K right now. They're talking about 32K in maybe the next version, which is really exciting. There's also ways to get around the context limit. People have done encodings. People have used bidding codings. They've used condensation methods, summary sessions in between there. So they've used hierarchical prompting to actually extend out that context window. We've run into that ceiling because we'll do long generative narratives, thousands and thousands of words long. There's also one of the problems about prompt engineering is these are stochastic. So a lot of the times the results, especially in something precision like finance or healthcare, you want one answer, you want a very deterministic one. So there are ensemble approaches to both overcome the stochastic nature of these results, as well as to deal with hallucinations. So ensemble approaches for prompt engineering have been very useful. Chain of thought is also something, especially when you're talking about something reasoning, showing your reasoning. So you will ask it a task and then you say, explain step by step. And there's a whole kind of variation of techniques in order to force the large language models to think step by step. And I've seen improvements on accuracy measurements anywhere from 7% upwards. And even more interesting, again, you have to take all of these metrics with a grain of salt because a lot of these academic papers, they're in isolation. They don't really transfer well into the real world. But the reflection and self-critique, where you actually you prompt the large language models in a cycle where it produces an output, then you have it critique it, and then you have it suggest improvements and then go back. And if you do this, it doesn't require a lot of cycles. We've done it maybe 2-3 times, and you pretty much asymptotically peak out at kind of the performance. And of course, one of the things, especially in healthcare security, is jailbreak, having people inject prompts and doing malicious things with these. So there are a number of techniques to kind of create a secure pen around these. I'll leave this up. This is, again, we have an advanced crowd here, it sounds like. So I will leave this up about, Graham Newbig did this, probably the most comprehensive analysis and also kind of touches to theoretical computer science about different languages, completeness. So the next thing I'd like to do is kind of survey the large language models and really kind of do as a ground reference, focus on GPT-4. There is Palm by Meta, and there is Palm by Google, and there's wait, let me see, Palm and and Meta does Llama, and of course there's a bunch of variations around that: Alpaca, Vincuna, Koala, and all these other ones. But they're pretty much interchangeable, from a large scale. But let's focus on GPT-4 and look at the limitations, the characteristics, the limitations. We'll talk about that in a bit. And the characteristics, one of the things that's very important, especially if you're processing a lot of text or documents, is how long the context window is. The other, sequential tokens. One of the interesting thing is that it's people normally think of these large language models, also called foundational models. Maybe that's better, because the modality isn't limited just to text. Any sequential tokens, whether it be music, whether It'd be financial time series data, whether it be word tokens. And of course, a lot of these modalities can be transformed from, for example, image into sequences. And that's why you see in all of these large language models that they're expanding their capability beyond text to text, text to image. They're going image to image, image to text, video, text to video, text to sound, sound to sound. So the modalities, the transformations into sequential is no limitations. Obviously, they're autoregressive and self-supervised learning, especially in the main training, which was one of the things that made this very scalable, no longer bounded by the limited, expensive label data. General to fine tuning. The fine tuning again, I think what ChatGPT did with their fine tuning. Again, we don't know what they did with 4 version, but it's probably modifications of what they published about Chat. And the emergent functionality is very interesting too, both from in terms of we're seeing things like reasoning, jokes, translations, Tamal that it's never learned on, acronym, mathematics, things like that. It's also worrisome, especially for the AI alignment community, because there's concern that it can, for example, get its own sense of will and objectives independent of the prompter or the engineers. There are a lot of variations of this. We have the commercial versions, and there's a big move for open sourcing this. We're seeing a lot of models come out that are trying to keep an open source alternative of this. And some of these are also trying to get around the censoring. There's concern about some of these large companies having a monopoly, being able to censor what people can and cannot do. And it comes especially important as these models basically infiltrate almost everything from office to Tesla vehicles to your smartphone, everywhere. Distilled models in order that you can put these on the edge of the cloud. And of course, I mentioned the uncensored versions there. The GPT-4. So there's a lot of jokes going around that OpenAI should call itself closed AI because the technical report didn't release a lot of details. It did release a fair number of metrics and performance metrics, but it didn't really reveal much about what you would expect from a traditional academic paper. The scale, the data set, and the training, the 3 big parameters. Up until now, everybody, I think, in the media has been focusing on scale, growing these. I think the 540 billion model is the ceiling right now, state of the art. But what I've been reading in the literature is that the data set quality and particularly the training, that those are 3 independent variables that number of people are trying to find out where you squeeze, where you apply your limited resources to get the most bang. And I'm reading a lot of the podcasts, a lot of the experts, a lot of the papers that the training and the data set are the top. So again, Sam Altman said just last week that it's a lot of little things that led to the noticeable improvement with GTP4 without revealing exactly. We talked also, multimodal, that GTP4 is not only text, but it's image. They haven't released that. There are some models out there that now combine those. They're not very large or powerful models, but they are proof of concepts at this point. Everybody's focusing on performance, and emergence is also kind of an interesting area for the reasons I said. So this is the technical report, if you want to reference it, and a couple of highlights I'd like to show out of this. Number one is you can see how this is kind of the inversion of the chart that you've probably seen, where the number of parameters going up, it's basically logarithmic or exponentially growing. This is the inverse. This is the loss. You can see the loss reducing, and this is the GPT-4. This is also interesting because it shows the delta between GTP3 and 3.5 and GPT-4. And the green is the excess performance. The interesting thing, there was one area it actually performed worse on, but you can see all the other areas, significant improvements. And again, not through any major architectural improvement. There was speculation that this was several orders of magnitude larger in parameter count. There's been some, kind of confusion about that, some doubt about that. Again, I think the best information I heard was that it was a lot of little tricks and techniques they did about cleaning data, preparing data, training data, and the training regimen. And here, just for your, just to be complete, they did a number of challenging benchmarks and baselines across traditional NLP, and you can see how GTP4 basically, eclipse the previous standards of both narrow AI, state of the art, as well as the general GPT 3.5, its predecessor. If we go down, here's kind of what is evolving. This is kind of a little concern that the AR arms race, and so a lot of people in academia. This was another thing that one of the CTO at OpenAI said, was that a lot of this, the AI, because the models have become so big, so large, that academia is going to play an increasingly marginalized role in this. They're going to only be a few large players who can afford to innovate, especially when it comes to the infrastructure. That creates a lot of problems because it makes everybody else a thin wrapper around these OpenAI or Google or Meta's offering. Again, data is new oil. The data sets are also pretty valuable, but now they're less so, because I don't know, some of you may have read this, that you can now synthesize a number of data. In fact, a lot of the new models, the open source models out of Stanford, Alpaca, and some of these others, they actually use Chat GPT-4 in order to synthesize training data that was used to fine tune open source models like Llama. And so there's some copyright issues there, because Llama, their parameters were leaked, but then they fine-tuned it on, and then there's terms of use about creating synthetic data sets using commercial large language models like GTP-4. So it's a little crowded there, but I do think data sets have become less critical than they were before. The training, I think, goes to the ML ops and your infrastructure. Do you have the capacity to do that? So again, that's going to be, maybe large corporate players could do that, maybe large academic institutions. It's not as restrictive as maybe just going the brute force on the parameter count. That ties into the operations. The multimodality, there's a big upside there. There's been some talk, some concern about we may have exhausted the good data, the good text data that's available to train these. And so I have read some research that says bringing in multimodal data, text and image, is very valuable, because they reinforce each other in latent semantic space, and they can actually, it seems to be valuable to bring in a different modality rather than the same amount of data in the same modality, because you're kind of, searching out more of that latent space. Embodied Palm E. I don't know if you've heard, OpenAI just announced their robot, which was entirely vaporware, but until recently. But they've hired somebody from Google, DeepMind, and as big as these large language models could potentially be in the virtual space, in the cognitive space, there is a tremendous market push for the physical work in the physical space to attach these large language models as a controller for a typical robotic system. So some of the considerations are the tools and automation. We'll go into those today. The cognitive disintermediation. So this is something that concerns a lot of people. There's been some reports by Goldman Sachs, OpenAI, Oxford, the Martin group over there have done a lot about the potential disemployment of a large part of the economy, a lot of the knowledge workers. And so, and certainly the Goldman and the OpenAI reports actually targeted those who are higher educated, making more than $80,000 a year. So there is a concern there. A lot of these also are a little bit disconcerting, because what we teach here at Kenyon is not just the technology, but also the larger social, environment of it, context. And so a lot of these are natural monopolies. Nobody wants the second best search engine. Nobody wants the second best lethal autonomous weapon. These are natural monopolies. I have played around with Bard, and when you're writing something like an academic paper or you're generating synthetic data, you will not, you're willing to pay more to get it correct. And also, people talk about the fifth industrial revolution, the World Economic Forum. We also teach that, but not as relevant to our talk today. Now, the risk with these large language models, just to enumerate them, I'm sure you're all very aware of these. They're probabilistic in nature. That can be difficult. A lot of times I was actually in medical school before I dropped out, and me coming from engineering and math, I was very always asked for a probabilistic, diagnostic with some error bars, and it's really not any in the way traditional medicine thinks about it. So that mapping is something that's going to be a culture shift, but also I think it falls on the tool makers, the engineers, more to accommodate the domain experts in medicine rather than the reverse. Everybody, well known about the hallucination and the false confidence it can display. Less so here, but certainly in text to image, we do a fair amount of that. We have issues of copyright, and they do see you see it more in image. So, for example, there is a Getty's Image is doing a class action suit with other artists, and I think point like 1/10,000th of a percent they can find almost duplicate. It looks like it's a duplicate. A lot of times you can see the watermarks appear. Bias, offensive, and dangerous information. For example, there was a large language model for a medical application in Japan that was suggesting euthanasia. That would have been fine in the Netherlands. In Japan, that's verboten. Uh, 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 Fairness, accuracy, transparency, and explainable AI are two more issues. These are large black box models, and certain regulations like lending and other things, you can't use these models. Privacy and security, always an issue. Low resource languages outside English and maybe Spanish and Chinese. When you start getting to lower resource languages, performance drops off a cliff often. Often you can get good results by translating into English and then back. um, Causality models and new knowledge. This is a more theoretical, what are the limitations of this? Very interesting. These large language models have demonstrated things like advanced thinking, reasoning, theory of mind of counterparties in terms of negotiation. One of the, I think, the most legitimate criticisms that I haven't seen is, can they actually build models of causality and generate new knowledge? Regulations, the liabilities. We're seeing a lot of people in the news. We were actually talking to some people in the EU about regulations around AI. And I wanted to show you this. For all of AI's shortcomings, I remember Elon Musk said self-driving cars will have to be 10 times safer than humans in order to be accepted. But if you look at the errors that these large language GPT makes, and you look at the errors humans make, there's actually a pretty strong correlation. So are we asking more of our large language models than we are asking of human physicians or nurses or PTs? That's one question to think about. So getting down to what we had headlined on the talk, extending these large language models. So one of them is several different ways they're extending them. They're putting these large language models into frameworks. Most famous of those is LangChain. And there's other frameworks that actually incorporate other, narrow AI models like Jarvis and Hugging GPT. These are akin, I think back to other things I've done in robotics. If you think about real-time robotic systems that have a messaging, right? And you have a controller. If you think about like a von Neumann machine that kind of controls execution, and they're using these large language models as the controller, and it's delegating out. It has a priority queue. It's basically coming up with execution graph or path, if you will. Automation is Auto GPT. There's a little more hype than there is substance here. I've played with some of these. They don't quite, and these are just basically you give these large language models a task and they break it down and execute it and delegate it. Haven't been too impressed, but they're definitely going in the right direction. Embodiment, they're attaching these to robotic systems. Google is kind of leading with that. And integration. So they're integrating these models not only in frameworks with tools and putting them in semi-autonomous agents, but they're also connecting it to the world. For example, connecting it to, TaskRabbit or checking accounts or, even, negotiations and things like that. There's some very interesting things I've heard in terms of the startup world about doing distributed autonomous organizations and things like that. So LangChain, let's start with LangChain. LangChain consists of several components. There's a prompt template that you can customize and extend. It has a memory beyond just the context window, explicit. There are various tools you can bring in, and some of the tools, for example, could be databases, Wikipedia, Wolfram Alpha, if you need a symbolic, really precise mathematical. And some of them are meta tools. For example, they can hook into Zapier, which has API connections to 5,000, services, SaaSs on the cloud. Of course, agents and agent executor, again, using large language models as a control unit. Here's kind of a good block diagram, and also semi-state diagram, how it goes. And so it starts with an agent, and the large language model is actually the one that controls it. And it has an agent that goes out and it can access tools, it can access other large language models, it can interact with the user. The user can kind of like you can put a user in the loop, a human in the loop, or you could have it run autonomously. So the user asks a question, it's sent to the large language model, which then basically decomposes that question into maybe an execution of separate tasks, and then comes up with an execution pass, and then it finds out what tools or what resources it needs to basically complete every single subtask. Sometimes subtasks will have to be decomposed into further subtasks. So again, it's very much like you might see in a TensorFlow execution graph or something like that. And if there's time, let me see, how are we doing on time here, Timothy? I have a couple notebooks I could show.
Sure, we probably got we want to save a little bit of time for discussion. People have been very quiet so far, but probably maybe 9 minutes before we want to, we can save 15 minutes for discussion today.
Okay. So I'll put a link to this too, if you're interested. This is kind of the LangChain, Hello World notebook. And it's you install it. I'm gonna have to change my keys here because I hard coded it in there, violating security. Let's go to the prompt templates. Okay, so here's the prompt templates. And we ask a question here. This goes to ChatGPT2. And here is the prompt right here, template. So this is a question. This is a chain of thought reasoning. And here you kind of leave it, you give the cue for the large language model to answer it, right? So this is no different than what you do as a single one. Here's where you actually chain it up. So there are several questions. So can Barack Obama have a conversation with George Washington? So you can actually chain this up. It makes several calls. It says George Washington died in 1779. Barack was born in 1961. And so it's able to infer that. So it's not just a 1 or 2, it's actually hitting the language model several times, getting several answers, and then actually, feeding it back and reasoning about that. So here is one where we load in a tool, and what is the year that Leo, let me see, agents and tools. So you got a tool. Let me go up to, oh, you know what? Let me see if these, yeah, so LangChain, again, it has, you can actually pass through the parameters to your OpenAI, your temperature, your top P, things like that. This is kind of interesting because this will explicitly show the chain of reasoning, and you get feedback from the machine. It's telling you how it's thinking about this. So what was the first film Departed? What was the year the film Departed with Leo DiCaprio released? And what is this year raised to the 0.43 power? So it goes out there. It's actually going out to Wikipedia. So it's you can kind of overcome some of the hallucinations because it has a ground truth if you have a reference. And it finds out, what year it appeared, and it finds out it's going out to Leo DiCaprio. And then it's actually it has calculators and scratch pads built in. Here's an example where it can overcome the limitations of the context window by using it actually has a directory. If you want it, you can write it out to file explicitly. There is an exhaustive log, just kind of like a syslog. If you're a Unix, sysadmin or something like that, you can debug it and see all the traces. You can also load, PDFs. You can load, Word docs, all of these other sources that could be out there. Let me see. Sometimes you can, this one is loading in a text. This is State of the Union. This may be and it brings in the text. It splits it up. There are a variety of ways to split it up. It vectorizes all of those. And then kind of like a recommendation engine or something like that. It can do, cosine similarities to do. Oh, okay. It can do cosine similarities and other things. I will just leave that there just to give you a feel of that. I'm getting the, and let's see here. Let's just finish through this section and then we'll do Q&A. So the auto GTP, here is a good diagram of how this works. Again, it's not that different, except it has calls itself and it goes in the loop. It has an optional, you can insert the user. For example, you can have it go completely autonomous. You can have it do autonomous for so many steps. You can have it basically verify, get permission from the human at every step. I actually had it working at the command line here. It's broken. The development's moving so quickly. It can be a little pricey to play with, some simple things. I was having it, for example, I'm a board member for a roundtable in New York. We were doing, looking for experts for a roundtable. And I had it like search out these. And they say like trivial tasks like that can cost about $14 per pop. So it adds up quickly. And let me see. Why don't so the DAO, I'll leave it at this. So the DAO is very interesting because this is a distributed autonomous organization where a lot of the operations in a business, there's a virtual organization. Like, for example, one of the examples I saw in a career was a translation. Well, you have a bunch of contractors and they don't contract or talk to anybody human. There's actually contracts in the blockchain where people negotiate and their work gets approved. And if it's approved, then, then payment is distributed. And so it's totally virtual. And I left this as kind of like a view to the future and the potential of this, because this is taking automation beyond just a large language model, but basically some tasks which you don't really need commercial space in downtown San Francisco with a bunch of account managers and accounts payable, accounts receivable. This has been a dream. It's been talked about for a long time, but now we have the Federal Reserve. We have certain governments now coming out with stable coins, and so I think with the changes in the landscape, the IRS, a lot of the uncertainty has kind of been played out about this. I think in the coming years, the DAO with a lot of this autonomous AI, you're going to see as a huge growth. And there are some off the radar startups that I've been hearing about too, incorporating these. Healthcare in particular, it would be a little more tricky to do that with regulation and single payer and the liabilities around that. But let me leave it there, Timothy, and leave some time.
Thank you, Professor. And I'm going to leave it open if you want to unmute yourselves and leave it open for questions or discussion. Or Professor, if you have questions for the participants in the lab today, now's a great time to also ask them.
Do apologize since I'm new to the group. I don't have a baseline. I didn't know what to speak about. I do have, I'll leave this in the startup here, but the other sections very quickly were the medical research with large language models. I did one about a taxonomy about the different applications that people are using AI, and especially these large language models. I talked about capabilities on medical challenge and reasoning in the clinic. There could be a lot of value there. And also more reasoning, and this kind of gets into prompt engineering and some very interesting figures, for example, about what is the difference between having a zero prompt and then maybe connecting it to a database and then maybe doing ensemble. The thing that really shook me is that these large language models, and this is a 3.5 version, the lift that you get from connecting it to a database was very minimal. These large language models know a lot of information. So, there's some kind of interesting ensemble, so some metrics that I've always wondered about how big of advantage. And then also just a little bit on the startup space. So I talk about some of the business challenges. I talked about, some of the industries and certainly finance and healthcare, because of a lot of the regulation and the criticality of the applications are a little bit less there. Where exactly where analysts believe a lot of the applications and the profitable, the low-hanging fruit to apply this technology. So back to you, Tim.
We have a question from Mr. Ferranti.
Yeah. Hi, John. Thank you, Timothy, for inviting us and for organizing this meeting. So I was curious about the DAO concept, and particularly about the fact that you said that it will be much harder to apply it to biomedical research. And the reason why, and particularly with regulation and things like this, and I was thinking like, if something, the fact that you have contracts that are done with specific verification algorithms, in a way actually makes levels the playing field, right? Because that means that like if you have a mandate for instance, for your machine learning model to be diverse, you enforce that level of diversity, you know, there is a threshold, you know, there is this certain groups need to be filled. To me, it seems like, and maybe I'm not seeing this from a very sophisticated perspective, but like to me, it seems that like having this form of machine learning verification is actually where regulations and things could work better than what we're doing right now.
Yeah, I agree with you. And, you know, my priors are from clinical. So a lot of the things I talk about is clinical because, you know, I think that's maybe the stereotypical idea. I think if you're talking about lab tests, if you're talking about, you know, subcontracting out, you know, some sort of, biochemicals and biomedical research, that is perfect for the DAOs. Where it's not is where you have a patient and where you have liabilities, where you have, other. Having worked in medicine, I remember, and this is 25 years ago, one of the reasons why I was so frustrated working in medicine, I first got in there, I thought, oh, you know, technical, you know, Matt, this is like Byzantine, all this paperwork, all these inefficiency. I'm going to be walk on water and part the seas and make all these wonderful things happen. There was an inertia built into medicine, partially because misaligned incentives, financial incentives, there's irregularities, the single payer, you know, the isolation from, you know, the healthcare consumer and the payee. So there's all these wrinkles in it, but I do see I'm very encouraged by the rationalization, the more logical, and this startup space is very, very big. And I do believe, for example, the application, the use case that you meant about testing is perfect. You don't have to worry about being sued out of oblivion because it's a standard practice. You send it off to, you know, a lab anyway, and you get your results. And someone pays it, and the results, the payments come in. You release the results to them, and they're attending for, or, you know, their care physician. That would be incredibly efficient.
Right. No, I was just curious if it's an interesting idea, and I was actually too curious to hear more the drawbacks. And I understand that there are drawbacks, like for instance, like, but mostly have to do because we haven't done the separation between, I think, what is the digital currency and this type of contracts. So if you see the two technology as distinct, then like I think this kind of DAO could be implemented in the government, in government agencies or something like this. But like, I don't see how it would work, obviously, with digital currencies.
I think one of the big watersheds that was hit recently is, like I said, the Federal Reserve has announced their own coin. A number of governments have also announced their own coin. So before, it was always like you're working in the shadows, and, you know, medicine and insurers, very conservative. They're not going to go for something. It's kind of analogous where we are with text to image. A lot of or text generation. A lot of companies, the thing that's holding them back is the liability of being sued, because they don't know where the liability, where the risks are, whether it comes from copyright or what happens if it says something wrong and who's to blame, you know, who do you sue? But I think, for example, that they've worked out all the tax. I think the IRS has pretty much worked out that governments are now behind it. I think there's been kind of a concerted attack on some of the other kind of wild form, if you will, coins out there. And so I do think it's kind of right. The thing that's been holding it back is, I think, is the questions about so many business, financial, legal questions about not only Bitcoin, but also liability. I remember I was looking at a startup with my brother, who's an anesthesiologist. He teaches at UCLA, and he's like, you don't understand doctors, they're never going to accept this. Patients, always want somebody to sue. You cannot take that away. And so I think a lot of these things, there's a human side here, there's a bureaucratic side, there's a government regulation and insurance reimbursement side that kind of distort the free market.
I can see that. But if you think about it, like doctors at the moment are really already contractors. Most of them are actually already under contract with the hospital. So if you say, I'm going to verify that contract, maybe if you explain it to them in terms of like kind of a reward by performance or something like that, it would be more acceptable.
You're right. A lot of these doctors have been converted into, with all these acquisitions and mergers, into employees. And so, they do what they do. I was listening to a lot of AI and healthcare, podcasts of the last 24, 48 hours. And the number one thing is like, it's staffing. Staffing is number one, retention, morale. And so, these automation tools, I think there's a surprising amount of inertia, judging from what I'm hearing from people coming back from these conferences and discussing what the major issues are. So DAO and these large language models and these frameworks all kind of line up with that. They have to be well designed, but the biggest thing for me is the liability, the human issues, the cultural and the legal and the financial.
What I haven't heard people discuss is the fact that in medical applications, we see the theory in terms of a medical doctor versus an AI-driven diagnostic or other applications. But frequently when I go to the medical doctor, I see a physician's assistant, and I don't see how much of a difference there would be between an generative AI response versus a physician's assistant. Neither one is a medical doctor, and both can make mistakes.
Yeah. Let me see if I can find that here. Let's see here. There was an interesting paper here about, so even on the GPT 3.5 codex, 5-shot chain of thought, it's approximately human level. And the current level is far above the average. And these are artificial because these are human tests. There's a lot of controversy about giving these. We've kind of maxed out on, you can't give an AI a human test because they're getting too good. And the problem is these are artificial because they're multiple choice. And so the real world is not discrete and multiple choice. It's continuous and there's wrinkles on it. But, Vinod Khalsa said about 10 years ago that it's going to come to a point where the information, the advice you get from an AI is going to be superior, cheaper, ubiquitous, easy to access, no waiting in a waiting room for 2 hours being exposed. And I do think we're at that. I'm a little bit skeptical because I grew up in a medical family and I've been there and I've seen how the sausage is made. And we've had with our own children some really bad diagnoses given. Doctors are like programmers, are like everybody else. There's a Gaussian distribution, and some are really good, some are really bad. All of them are overworked. So even if it's a first pass, I do see better care coming from this. And certainly if you're going to do something like go under the knife and do some major, you're definitely going to want a human. Insurance companies are going to want somebody to sign off on that. Hospitals are, patients are going to want maybe somebody to be on the hook legally, ethically for these things. But if you look at some of these papers, I'll post them. It's pretty good now.
Mandar, I see you have a question.
Yeah. So basically, once again, clinical background, interest in AI are all coming together in me, and that's where this question comes from. Actually, there are 4 facets. Let me try to see whether I can compact it down enough. So all of these summary prompts that are on current slide, all of these are tests for which the material is freely available on the internet. Many of these questions have been verbatim part of some Wikipedia article or somewhere on Reddit, somebody has written it and actually given the right answer. So there is a lot of discussion. So this is not an unbiased view whenever it comes to multiple choice questions that have been part of the literature for a long enough time. So take it with a grain of salt, what numbers you see over there. Second part is that when it comes to actually determining the diagnosis of the patient, etc., I am going to agree with William here that the physician assistant, although the person exists over there in the same role, but the role of physician assistant has never been to provide a differential diagnosis. It's just never that physician assistant pops in and says that, doctor, it could be the other disease too. It just pretty much never happens. Their role is to follow the orders. There are certain cases where communication is back and forth good enough that they're training to be a doctor. That's why a physician may ask them, is like, what do you think? And they would say something about it. So that role is a little bit different. So I hope that we are not going to put them together, but from the point of view of AI, it makes a lot of sense to provide a differential diagnosis. Given that healthcare field is actually evidence-based medicine, the evidence has to be there sometime before when that particular diagnostic technology, diagnosis methodology, or treatment modality was created. And that means there is a literature supporting it. That means all of these models, if they are working in their right mind and not hallucinating, they're more than likely to provide the right spectrum of diagnosis as a differential diagnosis from which a physician may choose. That brings me to the point of human in loop. Whenever these models are being built, they can definitely bring tremendous amount of efficiency in the routine workflows for physicians, for lab technicians, for PAs, for MAs, for nurses, in doing their menial tasks that are going to be repeated across the spectrum of diseases, across the spectrum of patients on a day-to-day basis, using a simple prompt that I want to prescribe this list of drugs to the patient. It already knows what is the schedule of the drug and this and that, because the database could be added in that. So menial tasks can be definitely handed over to that, but still, no matter what the task is, ultimately it needs to be checked by someone. Coming back to John's point of liability, who is responsible, how to hold large language models responsible. I sincerely don't think that, given that these models are foundational models, these are not tuned for a particular task yet. That's why these are foundation models. Until someone generates the library of the right kind of questions for that particular task and fine tunes these models for that task, the entity, the startup who is going to develop that database library and then claim that my model works 90% accurate on these situations, that becomes the liability. But the foundational model itself cannot be an entity that is liable. So either the startup who is going to be developing that supercharged model for a particular task and take the responsibility that we are claiming this much accuracy. Currently, the accuracy happens to be there. Large language models are, I didn't think that, but it happened to be really doing good on the medical tasks. I didn't train it. That was never an intent. That was just general structure of the language that was being learned. And through that, fortunately, we are getting these kinds of accurate results. So once we fine tune, there will come the part of liability. Who is fine tuning?
So can I just address 2
Sure.
points there, because you raised very good points. One of which is it just memorizing? Is there data leakage and these metrics are artificially inflated? They actually did. I encourage you to read this paper. It's a very excellent paper by Microsoft and OpenAI. It just came out on the 12th.
Yeah.
And if you read this, one of the things they did, they came up with this metric MELD, memorization using Levisham distance, and it was using precision recall. And they showed that they picked some of these U.S. medical licensing exam questions that were from recent years, and they searched the database and they basically did all they could. They knew some of the data was leaked in there, but when they compared the leak to the non-leak, they found that the performance change was very little. So it's that's one thing. The other thing, there's a question in the literature about we can't trust these these foundational models. We need to fine tune, we need to have accuracy. One of the things that was very interesting was that even these fine tuned models, 540 billion parameters, the FLAN Palm and the Med Palm, they were outproduced by 20 points by GPT-4. So there is a question. What they're finding is for smaller models, when you're down in the 7 billion, 11 billion parameter range, that fine tuning beats these these foundational models. But when you get larger, 175 billion parameters or so, then you're finding that even these larger models that are fine-tuned on medical issues do not perform as well. So it's surprising to me. I just read this week, and I double checked it. I could be wrong. I just read it, this paper. It's amazing. There's just so much we don't know, and there's so much research to be done in this field.
I completely agree. I just made a comment, but I'm with you there. Like, there is a lot to be discussed over here, especially when it comes to medical domain.
Yeah, and I won't stand by these because it's one paper. I'd have to see it reproduced. I would go with the prudent that you're advocating. Definitely human in the loop. Yeah, very, very conservative on healthcare.
Excellent questions. Professor, do you have any questions for the group that's still left on the call? I know that we're running a little bit over, but if people have to.
No, I hope I hit the right note and the level of abstraction. I was very nervous coming to the group because I didn't know who I was speaking to. So I hope people found it useful.
It was extremely useful, and the level of engagement has been phenomenal. Thank you everybody for it is 2:02. If people would like to hang around and ask more questions, if that's okay with you, Professor, I'm happy to keep the call line open. I just had an 80s flashback about a call line, but that's a whole nother conversation. Would people like to stick around to ask a few more questions? If not, I will just thank everybody. Professor, thank you very much for joining us today and leading this lab. We will reconvene on May 26th. If people have interest in topics or would like to lead a lab session, please don't hesitate to reach out to me. If you would like to share this network with your friends, please also pass their email along to me, and I'll be happy to take them through that process. Our profound thanks to you, Professor, for this excellent lab session today. And we look forward to seeing more of you in the future.
Thanks, Timothy.
Thank you all.